the chapter number 14, that is electric current and its effect in this video. Okay, so earlier we have learned what are electric currents in last year, right? We had seen some circuits also like this, in which there is a cell, there is a switch, there is a bulb attached, and all of them are attached with a wire. Okay, such circuits we had seen earlier. Now we'll see in detail how these circuits are made and what are the different symbols that we can use for showing these electrical components, that are the switch, bulb, wires, and the cell. Okay, so in this table 14.1 you can see the different symbols which are used in this chapter for drawing the circuits, right? The electric cell is represented by a long thin line with a short thicker line beside it. An electric bulb is drawn with a circle and inside it curved lines. When the switch is on, the 2 points are joined, and when the switch is off, the 2 points are not joined to each other. And a battery. Battery means two cells connected side by side. That is a battery, and a wire is shown by a line. Okay, so these are the different symbols, and these are very important. So you have to remember these symbols which are used for different electric components. Now many devices such as torch, transistors, toys, TV remote controls use batteries. Batteries, as I said you, battery is when two or more cells are connected with each other, we call it a battery. And in all these devices, we use batteries, that is more than one cell. So it is important that you understand the definition of a battery. So I'll tell you there. So a battery is when the positive terminal of one cell is connected to the negative terminal of the next cell. Such a combination of two or more cells is called a battery. Okay, you can see in figure 14.2, A and B, they have shown how more than one cells are connected with each other. Now in this figure 14.4, they have shown you how you can make a cell holder. Okay, so in a cell holder, what you have to do is you have to take a wooden uh, plank, and on the wooden plank you have to fix two metal strips, and to keep that metal strips tightly, you have to attach them with a rubber band, and in between these metal pieces you have to put two cells, and these metal pieces are connected on the other end with wires which we can use to connect to the circuit which we want. Okay, so this is how a cell holder is made. Now here in activity 14.1 they have shown that the bulb glows when the switch is on, and through this circuit diagram I'll just show you here. In figure 14.8 you can see the bulb is glowing, right? So this means the switch is on and the circuit is complete. On the other hand, in the figure 14.9, you can see the bulb is not glowing. Why? Because the switch is off and the circuit is incomplete. That is why the bulb is not glowing. Now, how does a circuit gets completed? In a bulb, what is there through which the circuit gets completed? So, in a bulb, you can see there's a thin wire called the filament, which glows when an electric current passes through it. So, it is the filament which glows and gives light, which is then being spread into the whole room or the place where it is being lighted. And if the filament gets broken up, so what happens? The circuit does not get completed, and because of that, we say that the bulb is a fused bulb. Okay. So this was the some introduction given to you that how a circuit is made, how a circuit is completed, and how the electricity flows through the circuit. And this blue box, it is important, in which they have mentioned that when the circuit switches on, the circuit is said to be complete. That is, the positive terminal of a cell, it is attached to the negative terminal, and when the switch is off, the circuit is incomplete. introduction, that is the how an electric circuit is made using symbols and how electricity flows through the circuit when the switch is in the on position, and how the electric circuit is broken when the switch is in the off position. Okay, now the next topic we are going to look into is heating effect of electric current. So you must have seen that when a bulb is being lighted for a long period of time, for a long time, you can see that it uh, gets heated up, right? It gets heated up. So what happens? Because the light gets heated up. Why? Because the electricity which is giving out light is also producing heat. That is why the the bulb gets heated up. Okay, so because of that, what is happening, how much electricity is being passed into that circuit? Half of the electricity is used in producing heat and only half of it is used in producing light. So that is one type of wasting of electricity, right? If in the bulbs and all, right? But this heat can also be used in a very productive way or in a very good way, or it can be useful. How? Now, in activity 14.3, they have shown you a circuit in which in between the two nails, they have put a nichrome wire. That is a combination of nickel and chromium metal, nichrome wire. And when electricity is passing through this in this circuit, and when the electricity passes through this nichrome wire, the nichrome wire gets heated up, and this heat can be used to do some work, to do something, right? Now how can that be possible? For example, in electric heaters, this is a figure shown to you of an electric heater. So in an electric heater, if such coils are kept, then that coils produce heat, and that heater helps to give out heat, which can be used to heat up the room in cold places. So in this way, through electricity, when electricity produces heat, that heat can be used in a productive way. So the coil that is kept inside this heater, it gets heated up when the current passes through it, and this is the heating effect of the electric current. So there are many devices which use this, and which we are using in our daily life. Okay, for example, room heaters, electric heaters used for cooking. So this coil of wire which is kept inside this electrical appliances to produce heat, they are called as the element. Okay, they are called as the element. So this is the same technology used, or the idea used in the iron that we use to make our clothes proper. In that also many such black coils are kept, which gets heated up when you pass electricity, and using that steam coming out of the iron, we are able to make our clothes proper, right? Other examples of it are immersion heaters, hot plates, irons, geysers, electric kettles, hair dryers. These are the different electrical appliances in which we are using that electrical appliances heat to get some work out of it. Yes. Now in the bulb, as I said you, when the bulb is glowing, when the filament is glowing, the bulb also gets heated up. Why? Because the electricity that is passing through the circuit to glow up that filament, half of the electricity is used up in producing the heat. So the scientists have thought of making such bulbs which use less amount of electricity and give more amount of light. So first they uh, made up bulbs called compact fluorescent lamps called CFLS. They were good. They were using less electricity and giving out light, but as they were using mercury vapor, so it was not good for the environment, for the nature. So they thought of researching something else which could give out more light and less electricity is consumed, and it can be used. So that were LEDs, that is light emitting diodes, which they made, which were very electricity efficient. how electricity that is used to light up the bulbs can be used efficiently so that less electricity is consumed and the light is produced. Okay, so we saw that it is the LEDs, that is the light emitting diode, which helps to use the electricity efficiently and produce more light. Now next topic here is electric fuses. Okay, so these electric fuses are used to break the circuit into any electric appliance so that it does not cause fire or it does not damage the electrical equipment when more current is passed into the circuit. So that is the main function of electric fuse, to break the circuit. Okay, to break the circuit, that is the main thing. So how the circuit is broken? In the you can see a big fuse is being shown in figure 14.14. In that you can see through this, between these two metal pieces a wire is attached. Okay, a coil of wire is attached. Now that wire, what happens, that melts when more amount of electricity passes into this fuse. Okay, and when more electricity passes, this wire melts and breaks, and because of that the electric circuit is not completed, which is that electricity does not pass to the electrical equipment. Okay, and because of that the more current is not going into the circuit, and the appliances which are connected in that circuit does not get damaged. Similarly, the figure 14.15 shows you the small fuse which are being used in electrical appliances to break the circuit when more amount of current starts to flow into the circuit. Okay, now this blue box is very important. In that they have mentioned two reasons how excessive current flows into a circuit. One reason is when the outer plastic covering of the copper wire it gets broken, then the copper wires touch with each other and may cause excessive amount of current to pass into the circuit. And the other reason is when more than, how much is the capacity of the circuit, more than the capacity of the circuit, electrical appliances are attached to that circuit, and because of which the circuit gets overloaded and starts to grab more electricity, and in that case there can be a short circuit and it can cause damage to the electric appliances. So these are the two main reasons how an excessive current can pass through any circuit. So electric fuses, as I told you, wires made from special materials melt quickly and break when large electric currents are passed through them, and these wires are used for making electric fuses. Okay, and the definition of fuse also: a fuse is a safety device which prevents damages to electrical circuits and possible fires, as I mentioned. Okay, now in today's era or in today's world, there's a new thing come up, that is MCB, that is miniature circuit breakers. In this what happens is, thus there is a switch provided, the switch automatically comes into an off position when more amount of electricity is passed into the circuit. So this is a very good thing that has been done, that it automatically switches off rather than cutting the whole electricity. And then again in the earlier one we had to connect that again, that wire in the fuse, to again complete the circuit. But here, because of this switch, the switch automatically comes down to the off position, and once when all the electrical appliances are properly, all the electrical connections are checked properly, nothing, no problem is there, then what you can do, you can just on this fuse switch to the on position, make it to a on position, and the electric supply will be completed and electricity will start flowing into the circuit again. So this is a very good thing that has come up, that is the MCB, miniature circuit breaker, right? So further, earlier this was used, that is these two, this one, but nowadays the other one which I told, that is the MCBs are being used. Okay, the next topic here is magnetic effect of electric current. So up till now we studied how heat is produced in an electric current. Now other thing, and how that heat is being used, right? And that heat and excessive electric current can also be harmful, not harmful but damage some electrical appliances, and also be very harmful for some life if there is a short circuit and all, and if there is a fire and everything like that, right? Now, the next thing that an electric current can produce is its magnetic effect. So, what is it? So, in this figure 14.17, they have shown a circuit in which the circuit is attached with a compass. That a compass which shows the direction. Okay. Now, and that compass is kept in a matchbox tray, and that matchbox tray is being wrapped with a piece of wire. Now, when electricity passes through this circuit and the electricity passes through this wire, the wire starts generating a magnetic area around it. And because of this magnetic field created, the needle starts to move because it gets attracted to that magnetic field. So that is why the magnet starts to uh, shake or change its direction. So from this circuit diagram, we come to know that the electricity also produces magnetic effect. Okay. Now it was the scientist called Hans Christian Ørsted who found out this magnetic effect produced by the electricity. So you underline this, that this is what the scientist called Hans Christian Ørsted also wondered. He was the first person who noticed the deflection of compass needle every time the current was passed through it. And then the electric current passes through a wire, it behaves like a magnet. Okay, so that wire becomes a magnet. This is the magnetic effect of the electric current, right? So this is one more thing that we are studying now, that is the magnetic effect. So when a current passes through a coil of wire, that coil of wire produces magnetic effect and acts like a magnet. Okay. Now the next topic here is electromagnet. So how this magnetic effect can be used to make electromagnets. Okay. So in this figure 14.19, you can see a circuit is connected to a wire which is wrapped on the iron nail. And when electricity is passed through this coil becomes a magnet and it starts to attract the metal pieces which are kept near the that coil or that wire, which has now become an electromagnet. Okay, so what are electromagnets? When electric current is passed through the coils become electromagnets. Okay, so the electromagnets can be made very strong and can also lift very heavy loads. Okay, if we take a big piece of metal and wrap it with a coil, and that coil of wire is connected to an electric circuit, and you switch on the electric circuit, that big metal piece will act like a magnet, and it will attract all the metal pieces which are in a dump or in a junk, in a very heap, or in very heap garbage, or in a very big garbage place. Okay, so examples of where electromagnets are used. So this is it. The electromagnets are used to separate magnetic material from junk. Doctors also use electromagnets to take out small pieces of metals which must have gone into the eyes. And electromagnets are also used for making toys. In many toys, electromagnets are also used. Now the last topic here is the electric bell, how an electric bell works. So it is same, the working of the electric bell is same as how the working of an electromagnet is. Because of the electromagnetic effect, the iron piece attracts and this hammer hits on the gong. So this I have shown you with a video, so hope you have understood this. already explained you all using a video that how an electric bell works. Hope you are clear with the concept. So I'll just repeat in this video that how an electric bell works. So in this in the figure 14.20 shows a circuit of an electric bell. It consists of a coil of wire. This is the coil of wire which is wound around the iron piece. Okay. Now the coil acts as an electromagnet. So when electricity is passed, this coil acts like an electromagnet. So what happens? An iron strip with a hammer at one end is kept close to the electromagnet. So you can see this iron um, iron strip with a hammer is kept close to this coil. Okay, so when electricity passes through this coil and this coil starts to generate the magnetic field, it attracts this iron piece towards it, right? When it attracts this iron piece, this hammer with iron piece with the hammer towards it, the hammer goes and hits onto the gong. Okay, now what happens when this iron strip with this hammer starts to move in this direction, the point of connection between this iron screw and this iron strip gets disconnected, breaks. Okay, when that breaks, the circuit gets incomplete. The circuit breaks because why? This iron screw is touching this iron strip, and when this iron strip starts moving towards the coil because of the magnetic effect, it gets detached from this iron screw, and because of, you can see that iron screw is connected to the circuit, so the electricity breaks, the current flowing through that wire stops. And when that current flowing through this iron through this circuit stops, this coil is through this coil the electricity is not flowing, and so there is no magnetic effect of the on the coil. And so what happens, the iron strip which was being pulled because of the magnetic effect, it comes back to its normal position and then again comes and touches with the screw. So when it again comes and touches with the screw, the circuit gets complete again, and the current flows in the coil and the hammer strikes the gong again. And this process, that is the touching of the iron strip, the attracting of the iron strip towards the metal piece, sorry, towards the coil, and then because of that moving of the iron strip towards the coil, the disconnection of it with the screw, this process is happening so fast that we are not coming to know that there is a break in the circuit inside the electric bell, and because of which the hammer strikes the gong every time the circuit is completed, and this is how the bell rings. Hope you are clear with this, uh, how an electric bell works. Okay, and hope you all are clear with what all topics we have learned in this chapter of electric current and its effect. First, we looked into the symbols used for each and every electric component. Then we looked into the heating effect of electricity. Then we saw into the magnetic effect of electricity, and then we saw that how when an electricity is passed through a coil of wire, how it can become an electromagnet, and how an electromagnet can be used to make a bell, to do the working of a bell. Hope you are clear with this. Thank you so much.